Friends, the last session we had ground wave propagation, skywave propagation. In ground wave propagation, higher frequencies are not used because more attenuation taking place. In the case of skywave propagation, if frequencies exceed 30 MHz, the signals are penetrate into the ionospheric layer. So, in order to have remedial for it, the another communications will be comes into picture. Nothing but the space wave communication. What is the space wave communication? The frequency range of this space wave communication between the frequency range 30 MHz to 300 MHz. So what is the principle behind the space wave communication? Just look at the figure. So this is a earth surface. It is like a earth, call it as earth curvature. So above the earth you have transmitting antenna and receiving antenna. So these two are visible to each other. So whatever the signal transmitted from transmitter and it is received by receiver. So this communication I can call it as line of sight communication. The another name for space wave communication is line of sight communication. So one of the method to transmit the signal from transmitter to receiver is nothing but line of sight communication. Okay, now still I'll explain this concept in detail with some other picture or some other diagram. Just look at this diagram. So as we discussed in the previous figure, let us assuming that the antenna, transmitting antenna Tx placed over here, and height of the antenna is mentioned as Ht. The antenna point is marked as T, and we have receiving antenna R, the height is HR1. See that the signal is transmitted from T to R without any disturbance by the earth. So this is the maximum range covered by the antenna placed between T and R. Next question, can we extend the distance? Yes, in what extent? See that instead of the receiving antenna R is replaced and we fix another antenna which having the height equal to HR2. So this marked as point S. Still the signal transmitted from the transmitting antenna T to the receiving antenna S. This is possible because see that here also the direct ray reaches the antenna S, but it just crosses the earth slightly. Then it goes to the receiving antenna S. Again, I move the receiving antenna to the point U. Still I am receiving the signal from the transmitting antenna to the point U. Now I go for another receiving antenna with height equal to HR4 at a point V. See that this is the case, the transmitting signal is disturbed by the earth. So the receiving antenna not able to receive the signal transmitted by the transmitting antenna. So this is not a line of sight communication. So the maximum range achieved by this communication as per as this example from T to U. So if exceed that, see that the signal is disturbed by the earth. Then from this we conclude that so this line of sight communication or spaceway communication depends upon the curvature of the earth and similarly the height of the antenna. Why? Because based on the curvature, for example, even in this case, if I increase the height of in the point V, if I increase the antenna height, so I can able to receive it. But the increasing antenna is very difficult. So I could say this space communication depends upon the curvature of the earth and the height of the antenna. So this all these examples, so there is a direct ray between the antennas. There is another way of possibility reaching the receiving antenna from the transmitting antenna by reflection by the ground. For example, the signal is transmitted by the antenna T, the signal is, instead of going directly from T to R, it also reflected by the ground, then it is reaches to R. This is also possible. So at a point R, there are two rays are received. One is direct ray, another one is reflected ray. So at receiver point R, so the sum of these two, direct ray and reflected ray, gives you the total electric field strength. Whether it is weak or whether it is strong depends upon the in phase or out of phase nature of the resultant field. And one more, this is by using line of sight. So I can say this communication also utilized for satellite communication also. How come means, so instead of having the direct ray and reflected ray communication, or instead of having the line of sight communication, the satellite is placed above the ionospheric layer, so that the signal is penetrated into the ionospheric layer, and that is taken by the satellite, and the satellite send the signal to receiving antenna that is received by the receiver, right? So this also possible. This is the in by using satellite communication, so this is the two way of propagating the signal using space wave communication. One is line of sight, another one is using satellites, right? So this is about space wave communication. Next we move on to some of the basic concepts of skywave communication. Yeah, before that we discussed ground wave propagation, skywave propagation and space wave propagation. See that all the three communications are represented in a single diagram. See that. So there is a earth. Here see that this is a transmitting antenna. So here it is transmitting antenna. See that this is a receiving antenna, right? So between transmitting and receiving antenna, see that here the path A. So path A, so between transmitting and receiving. So this path A is represented as ground wave propagation. See, this is mentioned as ground wave propagation. Then path B is called as sky or ionospheric propagation, because we already discussed the skywave propagation is taking place after reflection by the ionospheric layer, so that this layer is ionospheric layer, so it goes to ionospheric layer, then reflected back and reaches the receiving antenna. Then the path C is space wave propagation. So space wave propagation, see that there are two cases. One is direct wave. So this is a direct wave. As we discussed, there are two communication is possible. One is space wave, line of sight, that is direct wave and reflected wave combined at the receiver. See that this is the direct wave, and another wave. See that this wave is C. Here also mentioned C. This is called as a reflected wave. Both are combined over here. So this is nothing but the path C space wave communication. And again, the distance of the ionosphere and the another called as a tropospheric layer. This is actually for a space wave communication. Space wave communication taking place between the tropospheric layer. So this tropospheric layer distance is from the Earth is uh, 16 kilometer, and from troposphere to ionosphere the distance is between uh, 53 to 400 kilometer. So this is the range of tropospheric and ionospheric layers. So that this is one single diagram to represent how these three communications are three propagations are taking place between transmitting and receiving antenna. Okay, so next one is we move on to some of the basic concepts of skywave propagation. Basic means basic definitions. The first one is what do you mean by virtual height, HV. See that the top one so in the virtual height, so this one is nothing but the ionospheric layer, because we are explaining about some of the basic definitions of skywave propagation. So one of the important process of skywave propagation is the ionization process. So that here this is the ionospheric layer. Let us assume the signals are transmitted from this transmitter and it is refracted by ionospheric layers like this, and because after refraction by the layers of ionospheric layer, then it takes the bending path. So after taking bending path, it reaches the receiver. So this is the actual path of the propagation of the signal from transmitter to receiver. So that is called this way it is called as a actual height. But for the calculation purpose, calculation of virtual height, so this signal is projected direct and return to receiver very sharply like this. So this height is, I call it as HV, that is nothing but virtual height. So this virtual height is somewhat greater than that of actual height, because this is the actual height. So this is the virtual height, HV is the virtual. So just look at the diagram, the virtual height is greater than that of the actual height. So once if you know the virtual height of the layer, so you can find so what is the incident angle of the transmitting signal. So this is the definition of virtual height. So with reference to this, I can go for another definition. It's called as critical frequency FC. What is critical frequency FC? So critical frequency is defined for each layer. So we discussed earlier, ionosphere contain number of layers like D layer, F1 layer, F2 layer. So each layer, so we have to define what is the highest frequency reflected by the particular layer. So that defines the critical frequency of a particular layer. That is what defined as it is the highest frequency of a particular layer. See, highest frequency that will be reflected to earth by that layer at vertical incidence. Vertical incidence means so this like this. vertical incidence. So that is defines the critical frequency Fc of a particular layer. So if it is equal to Fc equal to 9 into root n, where n is equal to electron density. Why it is electron density means, as we discussed in the Skywave propagation, so there is a process called ionization process. So once ionization process is over, so that layer become a ionized layer. It contains the electrons. So if more number of electrons release, electron density is high. So it depends upon the distance, electron density also get varied. So that also taken into consideration. N is equal to electron density, because based on the electron density only the rays are get reflected in the case of skywave propagation. Okay, so next move on to the another definition is called as maximum usable frequency, that is MUF. So what is the difference between this MUF and FC means? This FC is also highest frequency, but the angle of incidence is vertical. Angle of incidence is vertical. But if the signals are not incident in vertical, so what will be the maximum frequency for that particular layer? That is defined by maximum usable frequency. See that this is also defined for the particular layer. It is also a highest frequency of the particular layer, but the angle of incidence is anywhere else other than the normal, that is other than the vertical incidence, right? That is what, see that it is the highest frequency. See that this highest frequency of wave that is reflected by the layer at an angle of incidence other than the normal, that is other than the vertical. So this is called it as maximum usable frequency. So here that incident angle cos theta I is equal to Fc by MUF. So incident angle Fc is nothing but the critical frequency, MUF that is maximum usable frequency for that particular angle. Okay, so this is nothing but the definition of maximum usable frequency. The last definition is that critical angle theta c. So what it means, I have to check whether the incident signal is reflected or refracted by the ionospheric layer. This is to be defined by critical angle theta c. So for that, let us see that. So this is my ionospheric layer. When theta incident, that is incident angle theta, is less than theta c, that is critical angle, so whatever the signal is transmitted, that is reflected by the ionospheric layer. So it is nothing but reflected wave. So this condition is not satisfied when incident angle theta is greater than theta c. What will happen is the signal is refracted. The signal is not reflected, it is refracted layer by layer and goes to the outmost layers. So the critical angle says that the critical angle is one of the important parameter when the signal is get reflected. So the incident angle theta is less than theta c, the signal is reflected back and this goes to receiver. So that is defined by the critical angle theta c. So this is about some of the basics of skywave propagation, and previously we discussed about some of the basic concepts of spacewave communications. Thank you students. Thank you all.